In the name of Allah, the most beneficent and the most merciful. Assalamu alaikum, my dear students. I hope you all are well. Alhamdulillah. This is Pakistan International School Taif's virtual learning class for subject Science for grade 6. Today is the lecture number 10 and we are going to start our chapter number 5. Atoms, molecules, mixtures and compounds. Chapter number 4 actually is not included in the scheme of studies. That's why we have skipped that chapter and we are gonna do chapter number 5, in which we'll study all about atoms, molecules, mixtures and compounds. Here we are on chapter number 5. In that, first of all, we will see about matter, an atom and a molecule. Then we'll see some elements, types of elements, metals and non-metals, some properties of them, and compounds, mixtures, and their uses, as well as we will see different techniques to separate out the mixtures. So let's get started. Atoms. Atoms and molecules is the first topic. Why? Because everything which is around us, that is made up of matter. And what is matter? You have studied in grade 5 that everything that is having weight, that is having mass and occupies a space, or that thing is having volume, that is called matter. And living or non-living things all are having matter. And the matter is made up of atoms. So atom is the basic structural and functional unit of everything living or non-living. So here we will talk about atoms in detail first, and then we will see how the molecules are made from the atom. So atom is the smallest particle of the matter, which takes part in chemical reaction, because atoms are the things by which different chemical reactions take place. Even we cannot see atoms because they are very, very small. But atoms, except noble gases, cannot exist independently. Like every type of atom, they have to react with other atoms to form a molecules, then they can be stable, then they can live. Otherwise, if there is only one atom, like this O means oxygen, there is one atom is there, it cannot exist independently except noble gases. What are noble gases? Noble gases are also called rare gases, and if we see in the science or in chemistry, there is a separate group of these noble gases. Why they cannot exist independently? Because when we see the structure of atom, then you can understand it properly. Because atoms outer shell, this is nucleus, this shell is having all complete electrons around it, 8 electrons. Okay, so here is one only, but if it is having all 8, so it does not need any other electron or any other partner to give the electron to that. That's why they are non-reactive gases as well, and they can live independently for a longer period of time. And these noble gases are, for example, they are uh, neon, argon, krypton. These type of gases are called noble gases, and they are having lots of uses in our daily life as well. Okay, so When atoms combine together, they join together, they form larger particles of matter. They are called molecules because atoms cannot exist independently. They cannot live freely. So they have to um just join with one another. They can be same or here, like you see here, they can be different. So then when they combine together, they form a molecule. So molecules can exist independently. Sometimes a molecule has the same kind of atoms, but sometimes different. For example, here is O. O. O is for the symbol of oxygen. Oxygen gas which we inhale. So if O, two O's or two atoms of O or oxygen gas, they combine, so they form O2 molecule. O2 means there are two atoms of O. So now it can exist independently. This molecule can exist freely. It can live freely. It can go anywhere freely. So the gas which we inhale, that is not only O, but it is O2. So sometimes different atoms combine, like here we can see that is water. The formula of water is H2O. Here we are having one oxygen because oxygen atom is bigger, and two hydrogen atoms, that is hydrogen, are smaller than, quite smaller than oxygen. So there are two atoms of oxygen, sorry, two atoms of hydrogen. The two atoms of hydrogen combine with one atom of oxygen, so they form H2O, means two atoms of hydrogen and one atom of oxygen. So this is also a molecule. So one molecule of oxygen gas is made up of two similar atoms, and water molecule of three atoms, two hydrogen and one oxygen. So if you see here, this is a common example, a graphite pencil, lead pencil, which we say. So this lead pencil is actually having graphite in it. Graphite is here carbon atom, but lots of carbon atoms are just stay together and they form graphite. So that is made up of carbon atoms. So just a brief explanation more about atoms. If you see here, atom is the word which means indivisible, means which cannot be broken down. The smallest particle of the matter. But the scientists have discovered that atom is not only the smallest particle, but it is having some fundamental particles in it also. So they are electron, proton, and neutron. If you see inside, that is nucleus, and in the nucleus we are having proton and neutron, and outside is having electron. Recall that in your mind because you have studied in a grade 5 that electron is outside the nucleus and it revolves like round and round like the earth revolves around the sun. That is having which charge? Yes, negative charge. And that is proton and neutron is inside, like the sun is inside the solar system in the center. So proton and neutron are present in the nucleus. This is also called nucleus, like the nucleus of the animal cell. So proton is having which charge? Positive. And neutron is having no charge. And electron is having negative charge. Yes, these are things you have studied in grade 5. So if you see this diagram, this is structure of an atom. And if you see how the electrons are revolving around the nucleus, here you see 1, 2, and 3 ways. So there are 3 electrons which are revolving around the sun. So if there are 3 electrons, it means it will have 3 protons inside it. Okay, so as many electrons, they are having as many protons inside it. And also it is having the neutron in the nucleus. So an atom is having 3 fundamental particles: proton, electron, and neutron. Atoms form molecules we have studied. So you see here, this is an atom, and if you see 1, 2, 3, 4, it is having 4 shells and it is having 4 electrons. Like it is moving, electrons are moving in its orbit. So every electron in the separate orbit, and as many electrons it is having as many protons. You see 4 protons and 4 electrons. So when atoms combine, so they form molecule. If you see here, oxygen, hydrogen, carbon, nitrogen, chlorine, and fluorine, they are atoms because they are just single, but they cannot exist independently. So they um, quickly combine with other atoms. For example, um, here is, you see hydrogen atoms. It combines with the nitrogen. You see this one, this green is nitrogen and these two are hydrogen. So it forms NH2. NH2. These are 2 carbon atoms. They combine together. C3, 3 carbon atoms are combined together. So they form what? Molecule. If you see, this one atom is of nitrogen, green one, and yellow one is of carbon. So both are combined. So that also forms a molecule. CH. H is for hydrogen and carbon, C for carbon. So they also form molecules. They're smaller molecules, but there are lots of atoms collectively combined. So they form a big molecules as well. If you see 2 carbon and 2 hydrogen, 2 carbon, the big one, and 6 hydrogen, like that, then they can move independently. Now, if we see here how a molecule is formed, this is hydrogen atom and this one is also hydrogen atom. And hydrogen atom and hydrogen atom, when they collectively combine, look, this is the shell around this one. So when they come closer together, so they form H2. H2 hydrogen molecule. So now this is what? Yes, H. How many atoms of H? 2, and 1 is O. So that is what? A water molecule. So here 2 hydrogen atoms and 1 oxygen atom, they collectively combine to form 1 water molecule. Now we'll see some elements. What are elements and what is the relation with the atoms and molecules? So you'll see here. If matter consisting of only one kind of atoms, so it is called element. One kind of atom. That is matter. Okay. So, but the atoms are all same. Like here, there are lots of examples. So if you take a piece of coal and you break it, this is coal and it is made up of carbon. Carbon. Graphite is made up of carbon. Coal is made up of carbon. Diamond is made up of carbon, but they are 3 different forms of carbon. But all that is due to the arrangement of carbon atoms in this matter. So when carbon will make bond means attraction. It is having attraction with carbon, and carbon, like all are carbon present inside it. So it is called an element, and that is coal. Here is another example, that is sulfur, that is powder form. And iron nail, all are iron atoms in that, Fe. So if you see this gold, all are gold atoms in that. No other element is present. So they can exist independently, but when they combine together, like C cannot exist independently, but when it combined with other C, then it can be free. So there are 109 elements known to the scientist. Around 92 are naturally found. Like in the nature on the earth, 92 elements are present. Other elements are made by the scientists by themselves by different like experiments. So elements exist in all three states. What are the states of matter? Just come on, hurry up. Yes, solid, liquid, and gas. So iron is a solid element. Yes, mercury is a liquid element. Yes, and oxygen, which we inhale, that is gas element. So mercury is that which we use in the thermometer to check our temperature, and that is in liquid form. Now I'll see some common elements and their symbols. That is very, very important, that why we study symbol. Actually, there was the scientist whose name was Dalton. Dalton was the scientist who used the symbols of the elements for the first time, because a full name is not convincible, or it's not easy to write every time, as well as not to remember easily. So they have just to use some symbols and abbreviations of these elements. Some are derived from English language and some are derived from Latin language. So if we see hydrogen, so this is H. Why we say it hydrogen? Because its first symbol, first letter is H. So we always use capital letters. And N is, do you know? That is a Latin word that is called natrium. Natrium. So natrium is the first two letters of Na that symbolized for sodium. So if you see here, there are some elements and their symbols. Aluminium, its first two letters are Al. Calcium, that is Ca. Carbon, C, that's the first letter. Look, there is calcium, carbon, chlorine, and copper, all just start from C. So scientists sometime have given the first two letters of that name as a symbol, like Ca. First will be capital, other will be smaller. And if we see here, that is chlorine. Here, the third letter is given for chlorine, Cl. Maybe another is having CH, so they are given just Cl. And this is copper. It can be CO, but CO is the name, is the symbol for, you see here, cobalt. That is another, so that symbol is C and small o, cobalt. Okay, so the scientists have given the name, Latin name, that is cupurum, and the first two letters of this cupurum is given as a symbol. Like gold, gold is the Latin name aurum, first two AU is given for the word gold. Hydrogen, yes, H. Iodine, I. Look, here is iron, again I. So scientists didn't give I and I for both or IR, so it's feasible to write ferrum. For that, ferrum is the scientific name, so first two letters Fe is given for the symbols. If we see mercury, mercury Its Latin name is Hydrargyrum. What is this? Hydrargyrum. So Hg is taken from Hydrargyrum, G here and H from here. If there are just only H, so there is hydrogen also. That's why they have given G from here. So it is suitable for that to write. Nitrogen N, oxygen O, phosphorus P, silver, again because silver, sulfur and sodium all are having SSS, starts from SS. So silver is given the Latin name and the symbol is A and G, argentum, and sulfur S, and sodium is again the Latin name, that is a natrium, and we have taken this symbol Na. So that is quite interesting. And right now, maybe you feel some difficulty, but later on, inshallah, you will be able to learn all these symbols according to their elements when these words will come again and again in your book. But you try to remember. Here are some symbols and different elements as well. If we see here, aluminium Al, argon Ar, this is noble gas, barium, boron, look, this is BBB, so this is barium for Ba and bromine for Br, calcium, chlorine, carbon, cobalt, we have seen this copper, cuprum, fluorine, F, gold, aurum, hydrogen, H, iodine, I, iron, lead, and this is lead, that is called plumbum in Latin word, so there's Pb from that, magnesium, Mg, and neon, that is also noble gas, that is Ne. If you see, because here is N, here is N, so Ne is written from here, and nitrogen, oxygen O, potassium K, that is carium, Latin word, silicon, silver, Ag, argentum, and sodium Na, natrium, sulfur, uranium, and zinc. If we see some classification of elements, so we will see there are two types of elements. Some are metals and some are non-metals. So about 70% elements are metals, and they are having similar, all are having almost similar properties. Number one, very important, they are shiny and gray solids. If you see, they are shiny or grayish in color, so they are metals. For example, aluminium, like this, rims of the wheels are made, and tires, the rims of the tires are made, and iron, nuts and bolts, and copper, this is having copper color, and these are used for electricity purposes, and silver and gold are used for jewelry, and they are having shiny, they are shiny, and they can be molded and shaped into by heating and pressing. When we heat them, they can be molded into different shapes. Why? Look, this is having different shape, this is having different shapes. We can make nail, we can make hammers, we can have different tools from iron, copper wire, so all like jewelry. Jewelry, that is that is a very good example. We can change their shape by heating them. They're good conductor of heat and electricity. They can, so if you just remember, they can be hot very easily, isn't it? When we go near to the fire and like that, that's why aluminum pots or utensils are used in the kitchens, as well as um, you see the examples, aluminium, calcium, copper, iron, lead, mercury, silver, sodium, and zinc are some metals. If we see non-metals, so opposite of them, they are not only solids, but they are liquid and gases as well. Solid non-metals are brittle. Brittle means they are very soft. They are not hard, they are very soft, but they cannot be molded into different shapes. And non-metals do not allow electricity and heat to pass. It means they are non-conductors. We don't say they are bad conductors. They are non-conductors because they cannot pass through electricity. If we see here carbon, chlorine, carbon is solid like graphite, pencil, like um, but that graphite pencil is can conduct electricity due to the arrangement of carbon atoms in graphite. Chlorine is a gas, hydrogen, nitrogen are gases, and sulfur is, as you have seen in the previous diagram, this is powder solid, and oxygen is also a gas. If you see here some metals, and they are solid, shiny, malleable, means they can be changed into different shapes, and they are good conductors of heat and electricity. You can see bronze, brass, steel, metal, sludge, copper, iron, and aluminium. So properties of metals, if you see, they are lustrous, shiny. You can see all are shiny. They are malleable, like they can be changed into sheets. If you see, they are heated up and they can be changed into different forms like that. Ductile means they can be changed into different wires. Excellent conductors of heat and electricity. Definitely, they can be molten as well. We can melt them in higher heat, and we can change their shapes as well, and electricity can pass through it through these copper wires especially, and they can form alloys. Alloys, what are alloys? We will talk them later on. Okay, if we see the physical properties of metals and non-metals, non-metals, here we are going to see non-metals, they can be solid, and this is a cylinder, oxygen cylinder, so gas is present in the cylinder, and bromine can be present in the liquid form. There are some other examples of non-metals. If you see, there is helium gas, hydrogen gas, that can glow, and that is present in the tubes like that, and that is nitrogen, which can be present in the liquid form, that is carbon in the coal form as well as in the diamond form, fluorine in the liquid form as well as oxygen in the gas form. That's why it can glow in the tube, and boron is also in the powder form. So boron is also non-metal. So we can compare here the properties. Metals are like shiny, and non-metals are dull. Ductile, they are ductile. We can change them into wires, but non-metals cannot be. Malleable, we can change them into sheets, but non-metals cannot be. Cannot having the property of malleability. They are having high melting and boiling point. They are having low melting and boiling point. It means it needs lots of heat to get it melt, and then they can boil. And they can conduct heat and electricity, and they are poor conductors. So they are having tensile strength as well. Like they are having strong. They are strong, like matter, and they are non-metals are not. So you can see some examples of these are metals and some non-metals as well. Okay, dear student, that's it for today. I wish you all the best. We'll see you in the next lecture. All the best.